morning, children. Exercise 4.1 Inverse trigonometric functions. Find the value of x. Given sin x equal to 0. Now we know sin x is 0 means x is equal to 0 or any pi. A little before we saw in the graph. So any pi only we write n pi. But they have given some restriction here. Minus 10 pi to plus 10 pi. X is equal to n pi as I derive from this equation. But I want it from minus 10 pi to plus 10 pi means compare. N is equal to minus 10. N is equal to 10. So the solution is x is equal to n pi whereas n is between minus 10 to plus 10. A simple problem where sin x equal to 0 comes. Remember, whenever sin x is 0, x is any pi. But they have given a restriction from minus 10 pi to plus 10 pi. Means that n value will be from minus 10 to plus 10. Second question, sin x is equal to minus 1. If sin x is minus 1, I will say x value minus pi by 2 or 3 pi by 2, 7 pi by 2. See, we have learned the 4 quadrants, 1, 2, 3, 4. The quadrants, x-axis starts with 0, pi by 2, pi, 3 pi by 2. My question is, sin pi by 2 plus 1 means I am here, first quadrant. Sin x value minus 1 means I am in third quadrant. So every time I am here, my answer is minus 1. See, when all I will be here, I go from this 3 pi by 2. Okay. Next, or else I can say 2 pi minus pi by 2. Or I go one full round. 2 pi minus pi by 2. If I go to 2 rounds, see. I am here. One round I go 2 pi. And this is 2 pi minus pi by 2. If I go to 2 rounds, 4 pi minus pi by 2. If I go to one more round, 6 pi minus pi by 2. One more round, 8 pi minus pi by 2. So every time I say it is 2 pi minus pi by 2 or 4 pi minus pi by 2 or 6 pi minus pi by 2 or in general if I cross multiply, it is 2 2s are 4. How many times I don't know. So let me say 4n pi minus pi by 2. Or this I can write 4n minus 1 pi by 2. So instead of checking like this way, it is every time I go to one 2 pi round and minus pi by 2. So how many times I don't know, let me call that as n. So 2 pi n minus pi by 2. Now this if I cross multiply, I get this answer. So whenever sin x is minus 1, I get 4n minus 1 pi by 2. 4n minus 1 pi by 2 is my answer which I have to compare with the given condition. Minus 8 pi to plus 8 pi. So put minus 8 pi less than or equal to this 4n minus 1 pi by 2 or this 4n minus 1 pi by 2 less than or equal to 8 pi. So here I cross multiply minus 16 pi I can cancel. Minus 16 less than or equal to 4n minus 1. Bring minus 1 this side. Bring 4 down which reduces to minus 3 by 4. So n is more than minus 3 by 4. Let me mark this minus 3 by 4 in the graph. Minus 3 by 4 will be somewhere between minus 3 and minus 4. So this is one answer that I got in the left limit. Coming to the right limit. 4n minus 1 pi by 2 less than or equal to 8 pi. Pi cancels. Cross multiply. Minus 1 to the other side. N will be 17 by 4. 17 by 4 is 4 1 by 4. So this tells me n is below 4 1 by 4. Where 4 1 by 4 will come in the graph? After 4. So my answer tells me n is above minus 3 by 4. But below 4 1 by 4. n is above minus 3 by 4 but below 4 1 by 4. Tell me which are the integers that come in. minus 4 cannot come because I am in minus 3, 3 by 4. To the right I want. So in between values, minus 3, minus 2, minus 1, 0, 1, 2, 3, even 4 will come because my question is 4, 1 by 4 below. So even 4 will come. So all these are my answers which I can rewrite. So x is 4n minus 1 pi by 2. When they give you the restriction minus 8 pi to plus 8 pi, n value is restricted to 0, plus or minus 1, plus or minus 2, plus or minus 3 and only 4. Find the domain of 2 sine inverse 2x minus 1 minus pi by 4. Now see, this 2 minus pi by 4 will not alter my answer. Domain depends on the function. What is the function? Sine inverse 2x minus 1. Now we already know what is domain of sine inverse x. We have learnt in the graph sine inverse x, the domain is only minus 1 to plus 1. So this number should fall only between minus 1 to plus 1. So in this question, whatever is the sine inverse argument, so put that between minus 1 and plus 1. Now simplify this and get what is x. Here minus 1 which I don't want. So add 1 everywhere. Minus 1 plus 1. Here also plus 1. Here also plus 1. This reduces like this. Again I want only x value. So 2x I don't want. So divide by 2 throughout. See, remember, whenever we are dividing, it should be a positive number. Positive number I divide means inequality is retained. So 0 as it is 0 by 2, 2x by 2, 2 by 2. So what is the value that I get? 0 to 1. So x lies between 0 and 1. The question is find the domain. Domain tells me what are all the possible values for x. So what are the possible values for x? Only between 0 and 1. So you can write between 0 and 1 or this inequality model, or else write the closed interval. Whenever equal symbol is coming, put closed interval. So domain is closed interval 0, 1. There is a similar question. Find the domain f of x sine inverse a particular argument is given. Now whenever we see a question and whenever there is a denominator, immediately declare. In mathematics, we are defining a function or anything, denominator should not become 0. So as long as we end the problem, let us remember x should not be equal to 0. Now this question also contains sine inverse. So let me write sine inverse, the domain is minus 1 to plus 1. So whatever is the argument given here, let me write it is between minus 1 and plus 1. Now can I cross multiply 2x on both the sides? Remember I told you earlier, whenever I multiply something, it must be a positive quantity. Positive quantity will not alter the inequality. For example, 4 greater than 3. All of us know. Let us multiply by 2. 4 2s are 8, 3 2s are 6. 8 greater than 6, is it true? Yes. So 4 greater than 3. When I multiply by a positive number, the greater than symbol is retained as it is. But if I multiply by minus 2, here I get minus 8, here I get minus 6. Can I say minus 8 greater than minus 6? No. Minus 8 is less than minus 6. See, whenever I multiply by a negative number, greater than becomes less than. So whenever we are in inequality problems, ensure that we multiply only by a positive number. So I cannot multiply by x because x can be any number other than 0. X can be any number, positive or negative. So to ensure it to be positive, let me multiply by x in the numerator and denominator. So 2x becomes 2x square. Numerator I put 1x. So multiply and divide by x. Now 2 is positive. X square by all means positive. A squared quantity is always positive. So multiply by 2x square throughout. Now the inequality is not altered. So multiplying by 2x square. Multiplying by 2x square means this will go here multiplying by 2x square. Now take this separately. Minus 2x square less than or equal to this separately. And this less than or equal to 2x square separately. So here let me bring this to the other side. So minus will go as plus, which is greater than or equal to 0. In both x is common. So taking x common, here I am left with x square plus 1. Here x is gone means 2x is left out. This is x plus 1 the whole square. And we know x plus 1 the whole square is a perfect square. Positive always. So it can be only equal to 0. So equal to 0 means x is equal to minus 1. What is the other quantity given? X. So x is greater than or equal to 0. Or this quantity does not give me greater than, that is always true. So only x is equal to minus 1 is another option. So the left side I get two answers. X is minus 1 and x is greater than or equal to 0. Coming up to this side, x into x square plus 1 less than or equal to 2x square. Bring 2x square to the left side. X into x square plus 1 minus 2x square less than or equal to 0. Taking x as common, I get x square plus 1 minus 2x. This quantity reduces to x minus 1 the whole square. Now less than or equal to 0 means, can a perfect square be negative? No. So x minus 1 the whole square cannot be less than 0. It can maximum be equal to 0. Equal to 0 means what? X is equal to 1. One answer over. Another condition tells me x less than 0. So this part gives me two options. X less than or equal to 0 or x is equal to 1. This part gives me two answers. X greater than or equal to 0 or x is equal to minus 1. But my question, I want the common intersected portion. See, this diagram tells x is positive. Greater than 0 and minus 1 is another answer. This diagram tells me x is less than or equal to 0 and x is equal to 1 is the answer. So what are the common portions? In both the places I get 0, one option correct. Here I get 1, here I get minus 1. But common shaded portion is not there. Here less than 0, here greater than 0 means both I cannot write. So the only options, I get three different numbers which will yield equal to 0 condition alone. So 0, minus 1, plus 1. But remember, beginning of the question we mentioned, because x comes in denominator, it cannot be 0. So 0 option also I have to exclude. So what are the only two answers? Minus 1, plus 1. So this particular problem, the domain is containing only two numbers. Usually domain, we give interval 0 to 1, 0 to 10, 1 to 2 like that. Here the domain contains only two numbers. This is not an interval. Only minus 1 and another answer is plus 1. Thank you.